Why do things fall? You'll say gravity. Newton said gravity. Your teacher said gravity. But here's what nobody told you. Newton never explained gravity. He described it. He gave it a name. He wrote an equation. But when you asked him why the apple falls, what actually pulls it, he had nothing. He called it action at a distance, a fancy way of saying, I don't know. For 200 years, we pretended that was an answer. That belief is not a little wrong, it's fundamentally wrong. Because Einstein didn't fix Newton's gravity, he deleted it. He showed us there is no pull, no invisible rope, no force reaching across empty space. There's just curved geometry. The floor tilts, and you slide. Right now, you're not being pulled toward Earth. You're being pushed by the floor through curved space-time, and your body calls that weight. That's not poetry. That's the actual physics, and it changes how you see every falling object, every orbit, every second of your life. Let me show you. Picture your bed. Not made. Sheets loose. Wrinkled in the middle. Now drop a marble at the edge. What happens? It rolls toward the center, toward the wrinkle, toward the dip. Here's the part your physics teacher skipped. Did something pull that marble? Was there a tiny invisible rope yanking it inward? No, the sheet was curved. The marble followed the slope. That's it. No force, no pull, no mystery, just geometry doing what geometry does. Now here's the thing. Put a bowling ball in the center of that bed. The sheet sags deeper. Drop the marble again. It rolls faster this time, curves around the bowling ball, maybe even spirals inward. You'd swear the bowling ball is attracting the marble. Wrong. The bowling ball isn't pulling anything. It's just sitting there, heavy, dumb, doing nothing. The sheet is doing all the work. The shape changed. The marble responded. This is where your intuition turns traitor, because you've spent your whole life thinking gravity pulls. That Earth reaches up with invisible fingers and drags you down. But that's just a story, a useful one, a wrong one. Try this right now. Stand up. Feel your feet on the floor. That pressure you feel? That's not gravity pulling you down. That's the floor pushing you up. Gravity isn't pressing you into the ground. The ground is accelerating into you through curved space-time, constantly, right now. Wait, I know how that sounds. The floor isn't moving. You're standing still. Exactly. That's the illusion. That's the magic trick Newton couldn't see. You feel weight because the floor won't let you fall freely. You feel force because something is stopping your natural motion. And your natural motion, in curved space-time, is to fall. The universe keeps strict books. If you're not falling, something must be pushing. That something is the floor, your chair, your bed. You've never felt gravity in your life. You've only felt things stopping gravity. Hold that satisfying answer. It's about to collapse. Because if gravity isn't a force, what is it? If nothing pulls, why do planets orbit? Why does light bend around stars? Why did Newton's equations work so damn well for 200 years? Here's where we go deeper. Newton gave us the what? Apples fall, moons orbit, tides rise. Einstein gave us the why. And the why isn't a force. It's not a pull. It's not action at any distance. It's shape. The shape of space. The shape of time. The shape of reality itself. Curved. Bent. Tilted by anything with mass. And everything just slides along that curve, following the straightest path it can. People say gravity pulls objects together, but that's just a label. Objects aren't pulled, they're guided by geometry, by the tilt of space-time. The universe doesn't reach out and grab, it sets the slope and lets things roll. So far we've learned. Newton described gravity but never explained it. The pull you feel is actually the floor pushing up. And something deeper than force, shapes how objects move. That something is space-time, and space-time doesn't negotiate. Let's get specific. You've heard the word space-time. Maybe you nodded along. Maybe you tuned out. Don't. Because space-time isn't a metaphor. It's not poetry. It's not some abstract idea physicists invented to sound smart. It's the actual fabric of reality, the stage everything plays on. And Einstein discovered something brutal about that stage. It bends. Mass bends it. Energy bends it. Anything with weight warps the stage around itself. And here's where it gets uncomfortable. When the stage bends, straight lines stop being straight. Think about that. You throw a ball. It arcs through the air, curves down, hits the ground. Newton said gravity pulled it down. Einstein said no. The ball traveled in a straight line, the straightest possible line through curved space-time. Wrong. Wait, a curved path is a straight line? Exactly. This is the concept that breaks people. So let me slow down. Imagine you're an ant on a basketball. You start walking, perfectly straight, no turning, but the basketball is curved. So your straight path eventually loops back. You end up where you started. From your ant perspective, you never turned. From outside, you walked in a circle. Same thing with space-time. The Earth curves space-time around itself. You throw a ball. The ball goes straight through that curved space. To you, standing on the ground, it looks like the ball curved down. But the ball didn't curve, space did. This is where your intuition fails. We see curves because we can't see space-time. We're ants on the basketball, blind to the real shape of things. Now here's what this actually implies. There's a word for these straightest possible paths through curved space. Physicists call them geodesics. Sounds fancy. It's not. A geodesic is just the laziest route, the path that requires zero effort, zero steering, zero force, and everything in the universe follows geodesics, unless something stops it. The moon doesn't orbit Earth because Earth pulls it. The moon orbits because space-time around Earth is curved. The moon follows the tilt. It's falling, constantly, in a straight line through curved space. That straight line happens to loop around Earth. Beautiful. The moon has been falling for 4 billion years. It never lands because the curve of space-time keeps bending its straight path into a circle. No rope, no pull, no force reaching across the void, just geometry enforcing itself. This isn't philosophy, it's accounting. The universe calculates the shape of space-time. Objects follow, no exceptions. People say the moon is held by Earth's gravity, but that's just a label. Nothing holds the moon. The moon is free, freer than you. It feels no force, no weight, no tug. It just falls forever along the curve. And here's the part nobody tells you. You could feel that same freedom. If the floor vanished right now, you'd fall. And in that fall, that pure, uninterrupted fall, you'd feel nothing. No weight, no pull, no gravity. Astronauts on the space station, they're not floating because gravity is gone. Gravity is absolutely still there, almost as strong as on Earth's surface. They're floating because they're falling freely along the geodesic. And when you fall freely, gravity disappears. The universe keeps strict books. Force only shows up when something blocks your natural path. Remove the block, remove the force. Think about what just happened. We deleted gravity as a force, replaced it with shape, and suddenly astronauts floating makes perfect sense. The mechanism isn't mysterious, it's inevitable. The year is 1907. Albert Einstein is not famous yet. He's a patent clerk in Switzerland, 28 years old, reviewing technical drawings, paying rent. But his mind is somewhere else. He's stuck on a problem, a big one. Newton's gravity works. It predicts eclipses. It explains tides. It got us to the moon, eventually. But Einstein sees a crack. Newton's gravity acts instantly. The sun pulls Earth right now. No delay. No signal traveling between them. That's impossible. Einstein already proved nothing travels faster than light. not information, not force, not anything. So how does Earth know where the sun is? How does gravity reach across 93 million miles in 0 time? Newton had no answer. Einstein needed one. And here's the moment everything shifts. He's sitting in his chair, daydreaming, and a thought arrives. A man falls off a roof. Brutal. But Einstein isn't thinking about the landing. He's thinking about the fall. What does the man feel while falling? Before he hits the ground? Nothing. No weight, no pull, no gravity. The falling man feels like he's floating, weightless, free. Einstein called this the happiest thought of his life. Sounds strange. A man falling to his death sparks joy? But Einstein wasn't being cruel. He was seeing something. If falling cancels gravity, if free fall feels like zero gravity, then gravity and acceleration must be the same thing. Wait, the same thing? Let me say that again slower. Stand in an elevator. The cable snaps. You fall. During that fall, you float. Pencils float beside you. Your keys hover. You feel no weight. Now imagine a different elevator, deep in space, no planets nearby, no gravity anywhere. But the elevator accelerates upward, fast, constantly. Your feet press against the floor. Pencils fall when you drop them. Your keys feel heavy. You feel weight. Einstein asked the obvious question. Can you tell the difference? Can you tell if you're standing on Earth or accelerating through empty space? No, you cannot. There is no experiment, none, that can distinguish gravity from acceleration. This is where your intuition turns traitor. Because we treat gravity as special, a fundamental force, something different from everything else. Einstein said no. Gravity and acceleration are twins, identical, indistinguishable. And here's what this actually implies. If acceleration curves your path through space, and it does, then gravity must also curve your path through space, not by pulling, by bending the space itself. This wasn't a guess. Einstein built the math. 10 brutal years of equations, failed attempts, sleepless months. But he needed proof. The universe provided. Mercury, the closest planet to the sun, the fastest orbit, and a tiny wobble Newton couldn't explain. Mercury's orbit shifts. Slightly. Each lap around the sun, it rotates a little extra, a fraction of a degree per century. Newton's equations predicted this wobble would be a certain size. They were wrong. Not by much. A tiny error. 43 arcseconds per century. But Einstein's curved spacetime, his geometry-based gravity, it predicted the wobble perfectly. Exactly 43 arcseconds. Reality doesn't issue refunds. Newton's invisible pulling force couldn't explain Mercury. Einstein's curved geometry could. The math wasn't just elegant, it was right. People say Einstein corrected Newton, but that's just a label. He didn't correct Newton. He replaced the entire framework. Deleted force, installed shape. Gravity went from being a mysterious pull to being pure geometry, the universe curving around mass, and objects following that curve like marbles on a bedsheet. No rope, no reach, no action at a distance, just the tilt of spacetime. And everything, planets, light, time itself, sliding along. So far we've learned. Einstein saw that falling cancels gravity. Gravity and acceleration are the same. Mercury's orbit proved curved spacetime matches reality better than invisible force. But proving geometry beats force? That required something more dramatic than a wobbling planet. It required bending light. Here's a test you can run in your mind. No equipment, no math, just logic. Picture an elevator again. Deep space, no gravity, just empty black nothing outside. You're inside, floating. Now the elevator accelerates, upward, fast. Your feet touch the floor. You feel weight. Pencils fall when you drop them. Good. Now do this. Shine a flashlight across the elevator, from one wall to the other, perfectly horizontal. What happens? Here's the part nobody tells you. The light leaves your flashlight traveling straight. It always travels straight. Light doesn't curve on its own, but the elevator is accelerating upward. By the time the light crosses the room, the elevator has moved. It's higher than when the light started. So where does the light hit the opposite wall? Lower than where you aimed. From your perspective inside, the light beam curved downward. You shined it straight. It landed low. The path bent. Wrong. The light didn't bend. The elevator moved. But you can't tell the difference from inside. And here's where it gets uncomfortable. Remember Einstein's rule? Gravity and acceleration are identical. No experiment can distinguish them. So if acceleration makes light appear to bend downward, gravity must do the same thing. Stand on Earth. Shine a flashlight horizontally. The beam bends toward the ground. Slightly, imperceptibly, but it bends. Not because something pulls light. Photons have no mass. Gravity can't grab them. The space itself is curved. Light follows the curve. Think about what just happened. We proved light bends near massive objects. Not through experiment yet, through pure logic. If gravity equals acceleration, and acceleration bends light paths, then gravity bends light paths. Simple. The universe doesn't negotiate. This was Einstein's prediction, published in 1915. Light passing near the sun should curve. Stars behind the sun should appear shifted from their true position. Wild claim. Nobody had tested it. But the logic was airtight. The thought experiment was bulletproof. If gravity is geometry, if space-time curves around mass, then light must follow that curve. No exceptions. Try this right now. Grab your phone flashlight. Shine it at your wall. That beam is bending, right now, toward the floor. By an amount so tiny you'd need atomic clocks to measure it. But it's bending. Because space-time between your hand and the wall? Curved. The constant is enforced. Light obeys geometry, not force. But a thought experiment isn't proof. Einstein needed the universe to show its math. He needed an eclipse. You used curved space-time today. You didn't notice. Nobody does. But every time you open Google Maps, every time your phone tells you where you are, you're relying on Einstein being right. GPS, 31 satellites, orbiting 12,000 miles up, each one carrying an atomic clock precise to 1/1000th of a second. Your phone listens to those satellites, measures timing differences, triangulates your position. Simple, except it shouldn't work. Here's the part your physics teacher skipped. Those satellites are high up, far from Earth, in weaker gravity, and time up there runs faster. Not metaphorically, not poetically, actually faster. Clocks on GPS satellites tick quicker than clocks on Earth's surface, by about 45 microseconds per day. That sounds tiny. Wrong. Light travels 186,000 miles per second. In 45 microseconds, signals drift by miles. Your GPS would be useless. It would place you in the wrong neighborhood, wrong city, wrong country by the end of the week. But GPS works because engineers correct for curved space-time. They program the satellites to tick slower on purpose. They adjust for Einstein's geometry. They account for the curve. This isn't preference, it's accounting. Without relativity corrections, GPS fails within minutes. With them, it pinpoints you within feet. Every rideshare you've taken, every food delivery, every airplane landing, curved space-time made it work. Now watch what this implies. Time itself bends near mass. Not clocks, not mechanisms, time. The actual flow of seconds stretches and compresses based on how deep you sit in a gravity well. Your head is older than your feet, literally. Your head is further from Earth's center, weaker gravity. Time runs slightly faster up there. Over your lifetime, your head ages about 90 billionths of a second more than your feet. Meaningless for biology, profound for physics. People say time is constant, but that's just a label. Time is negotiable. Space-time curves. And the curve affects not just space, but time itself. Hold that thought. Here's an experiment you can verify yourself. Look up the 1971 Haffel-Keating experiment. Scientists flew atomic clocks on commercial airplanes, eastward and westward around the world. When the planes landed, the clocks disagreed, by nanoseconds, exactly as Einstein predicted. Clocks that traveled faster and higher measured different time. Not broken clocks, correct clocks, measuring real time dilation. The universe keeps strict books. Mass curves spacetime. Curved spacetime changes time's flow. Clocks prove it. GPS depends on it. Newton couldn't explain this. Invisible pulling force has no reason to slow time, no mechanism to stretch seconds. But geometry? Geometry explains everything. The curve is real. The time dilation is real. Your phone proves Einstein right 1,000 times per second. But satellites orbit close. What happens when space-time curves severely? When mass becomes monstrous? Light reveals the answer. Point the telescope at a galaxy. Not just any galaxy, a massive one. Billions of stars packed tight. Enormous gravity well. Now look behind it. Wait, you can't look behind something. It's in the way. Wrong. You can see behind it, because light bends. This is gravitational lensing, the universe's most dramatic proof that gravity is geometry. Here's what happens. A distant galaxy sits far behind a closer massive object. Light from that distant galaxy should be blocked, hidden, invisible. But space-time around the closer mass is curved, severely curved. Light from behind follows that curve, wraps around, reaches your telescope. You see what should be impossible. And here's where it gets even stranger. You don't just see the hidden galaxy once. You see it multiple times. The light wraps around different sides of the massive object. Multiple paths, multiple images, same galaxy, 4 copies, arranged in a cross. Astronomers call this an Einstein cross. Beautiful. Not beautiful like poetry, beautiful like a receipt, a cosmic proof of purchase for curved spacetime. Think about what just happened. Light traveled billions of years, hit a gravity well, bent around it, split into multiple paths, arrived at Earth showing us 4 copies of one galaxy. No force pulled that light. Nothing grabbed those photons. Space-time curved. Light followed. The constant is enforced. People say light travels straight, but that's just a label. Light travels along geodesics, the straightest possible path through curved space-time. When space bends, straight bends with it. In 1919, Arthur Eddington tested this during a solar eclipse. He photographed stars near the sun's edge, compared their positions to when the sun was elsewhere. The stars had shifted. Their light bent, passing near the sun, exactly as Einstein predicted. Headlines went global. Einstein became Einstein. But eclipses showed tiny bending, arcseconds. Galaxies show severe bending, multiple images, rings of light, cosmic magnifying glasses. The universe doesn't whisper, it screams. Gravity is geometry. Light proves it. Not on paper, not in theory, in photographs. Hubble telescope captured thousands of these, rings, arcs, crosses, every one of them a receipt, every one of them saying, Newton's pull doesn't work here, only Einstein's curves. So far we've learned, thought experiments predicted light bends, GPS satellites prove time curves, gravitational lensing shows space-time bending light across billions of years. Force can't explain any of this, but shape explains all of it. Now we go deeper. Let me say that again. Gravity is not a force. It never was. Newton gave us a useful lie, a beautiful equation, a powerful tool. But tools aren't truth. The truth is weirder, more elegant, more unsettling. You are not being pulled down right now. The earth beneath you is curving space-time. Your natural motion, your default state, is to fall, to follow the geodesic, to drift freely through bent space. But the floor stops you. The floor accelerates upward through curved space-time, constantly. It rams into your feet, blocks your path, and you call that sensation weight. Here's the part nobody talks about. Gravity doesn't pull you down. The floor pushes you up. Your entire experience of gravity is actually the experience of being stopped, interrupted, blocked from your natural free fall. This isn't preference, it's accounting. Every force you feel, something blocking a geodesic. Chair pushing your back, bed pushing your body, ground pushing your feet. Remove the blocker, the force vanishes. Jump off a diving board. For that brief moment you feel nothing, weightless, free. Not because gravity disappeared, because nothing is stopping you anymore. People say weight measures gravitational pull, but that's just a label. Weight measures how hard something resists your natural motion. No resistance, no weight. Astronauts prove this daily. Think about what just happened. We flipped everything. Down is not a direction something pulls. Down is the direction space-time tilts. Weight is not gravity pressing you. Weight is the floor pressing back. Falling is not failure. Falling is freedom. The universe doesn't reach out and grab objects. It sets the stage, curves the geometry, then steps back. Everything else is just objects following the tilt. And here's where it gets uncomfortable. Time is part of this curve, not just space, space-time. Near mass, time slows. Far from mass, time speeds up. Your motion through time pushes you toward massive objects. You fall into the future slightly slower near Earth's surface. Your body naturally moves toward where time runs slowest. Brutal. Gravity is a slope in time. You roll downhill, toward slow time, toward mass, not because anything pulls, because geometry has a gradient, and you follow it. The universe keeps strict books. Space-time curves, time dilates, objects follow geodesics, nothing is pulled. Newton saw the shadow, Einstein saw the shape casting it, and that shape isn't a force reaching across empty space. It's the fabric of space itself, bent, curved, tilted by everything with mass. The question was never what pulls things down. The question is, why does down exist at all? And now you know. Down is where space-time tilts. Gravity is the tilt, nothing more. So where does this leave us? Newton looked at falling apples and invented invisible rope. Einstein looked at falling people and saw curved floors. 200 years apart, same observation, completely different universes. Here's what I want you to carry. Every time you drop something, you're watching geometry. Every time you feel heavy, you're feeling resistance. Every time you orbit, you're falling in a straight line through bent space. The pull was never real. The curve was always there. Try this right now. Drop something small, a pen, a coin, your phone if you're brave. Watch it fall. That object isn't being pulled, it's following the tilt, obeying the shape, sliding down space-time toward where time runs slowest. And for that brief moment of falling, it feels nothing. No force, no weight, no gravity, just freedom. You felt that freedom, every jump, every stumble, every dream where you're floating. That's not the absence of gravity. That's gravity's true nature, finally revealed. Reality doesn't issue refunds. Newton's force worked for predictions, but it was never the truth. Einstein showed us the truth. Geometry, shape, curve. And here's what haunts me. If gravity isn't what we thought, if that fundamental force was an illusion this whole time, what else are we getting wrong? What other invisible ropes are really just tilted floors? What other forces are just shapes we haven't recognized? Leave me your answer below, because between Newton and Einstein, there wasn't just a gap in time, there was a gap in reality, and we've been living in that gap our whole lives.